Good morning, students. Assalamu alaikum. Now, today we'll discuss something on the transient analysis as I have already provided you the notes. So, let us see some basics of the transient analysis. Now, in a transient analysis, we have three passive elements. Resistor is a static element, and inductor and capacitor are the two dynamic elements. Inductor and capacitor are also called energy storing elements. Inductor stores energy in the form of current, whereas capacitor stores the energy in the form of the voltage. So these two passive elements will be mainly involved in dealing with the transient analysis. So what is basically in a transient analysis? We need to analyze the behavior of the inductor and capacitor before and after the switching. That is, once we perform the transition, once there is a transition, that means when the operation is performed before and after the switching, when the operation is performed in the sense that whether we close the switch and whether we open the switch at the time t equal to 0, then we need to see the behavior at t equal to t less than 0 and t greater than 0. So we have three times. This topic will be dealing separately. T equal to 0, then we have t equal to 0 minus, t equal to 0 plus. We also call it t less than 0. We also call it, this is t equal to 0, we call it t greater than 0. So we need to see if we are performing, this is the transition time. This is the time at which a particular operation is performed. That is whether the switch is opened at that time, or whether we are closing the switch or whether we are opening the switch. This time is time t less than 0, t less than 0 or t equal to 0 minus the time when this is the time before, or a past time when the transition has been, when we are performing the transition before that, the past time. Suppose at t equal to 0 the switch was closed, so at t equal to 0 minus the switch will be opened. So this is the time before performing, before we are performing any operation. So this is the time t equal to 0 plus is the time after the operation has been performed on the switch. Whether at t equal to 0, suppose switch was closed, then at t equal to 0 switch was closed, then for the t equal to 0 plus also switch will remain closed. So this is the way. So this is the past time when the operation has been performed, the prior to that time, and this is the time after the operation has been performed. So those two times, those topic will be dealing separately. So to understand this position of transition from one position to another position, this we have to understand for the inductor and capacitor. So basically, in order to understand this transition or the transient analysis, we need to understand the two phenomena. Two phenomena involved are charging and discharging. Now, first of all, we'll be generally dealing with the charging and discharging. We'll take the standard and the normal discharging equations, and we'll see what is the standard charging, what is the standard discharging, and so on and so forth. Now, first I have taken the discharging. Discharging I have categorized into the two categories I have made for the discharging. The number one is a standard discharging, another is a normal discharge. So we need to understand these phenomena properly. Now let's say I have taken a general discharging equation y of t, which is a dependent variable, y naught initial value, it is per minus t by tau. Tau is a time constant. It can be a time constant for any network, whether that network is a RC network, RL network. And please make sure that we are first dealing with the first order networks here. We are not dealing with the second order networks. This is for the first order networks we are dealing. So let's substitute the value of this t. This is a standard equation we have taken, a standard discharging equation we are calling it. So we'll substitute the value of t. Starting, we'll substitute t equal to 0. So it will come y naught equal to e raised power minus 0. So that will be, anything raised power 0 is 1, y naught will get the initial value. Second, we'll substitute t equal to tau, y naught e raised power minus 1. So we'll get 0.368 y naught. Third, t equal to 2 tau, y naught e raised power minus 2, that will be 0.135 y naught. Fourth, t equal to 3 tau, y naught e raised power minus 3, 0.048 y naught. So on and so forth. We'll go on substituting the value as t equal to 4 tau, t equal to 5 tau. And finally, when we'll reach to t equal to infinity, we'll see that the value will be 0. So this very clearly, if we analyze from the beginning, if we are substituting the values from t equal to 0 up to t equal to infinity, we'll see that the value of this equation, the values on the right hand side will keep on decreasing. So first we have y naught, then it will decrease to 0.368, then further it will decrease to 0.135 y naught of the initial value, 0.048 of the initial value y naught, 0.01, and so on and so forth. Finally, at t equal to infinity, it will settle down at value 0. So if we will analyze this, this is a decreasing function. So if we have the graph, if we analyze, if we can see graphically this equation, t is on the time axis on the x-axis, we have y of t on the y-axis. The first value of this equation will be y naught, and then so on and so forth. 2 tau will be there, 3 tau will be there, 4 tau will be there. We can see the value of t equal to tau. The value will be 0.368. Value of 4 tau, which is normally called settling time in case of control system. 5 tau is the settling time in case of the network. So t is equal to 4 tau. We can see the value is 0.018. So value will be somewhere here. And finally, the value will settle down at t equal to infinity time. The value will be 1. So very clearly, a decreasing curve whose initial value is y naught, and final value is 0. So this is called the standard discharge, where it will start at some value and finally it will settle down at value 0 when the time will be infinite. So we call this as a standard discharging equation. So this is the way we will relate this standard discharging and charging with our inductor and capacitor, and we'll see later. But first of all, the concept of standard discharging is very clear. It will start at some value and then finally it will settle down at value 0 when the time will be infinite. That's all. Thank you.